So this brings us to the second session in the Modularity Visions track this year, which is with the invited talk by Gilad Bracha. Gilad is currently a senior vice president at SA Labs in Palo Alto. No? Oh, you're a vice, just a regular vice president? Okay. He was previously a distinguished engineer at Cadence, and before that a computational theologist. That's got to be the best job title, a computational theologist and distinguished engineer. He's done a lot of interesting and innovative work on languages and language features over the years, as many of you probably know. Before joining Sun, he worked on Strongtalk, an efficient implementation of Smalltalk with an optional incremental type system. The type system being the part that Gilad focused on.
We could play with it.
And included mix-ins at the Smalltalk level. He was a co-author of the Java language specification. He was also creator of the Newspeak language, a highly dynamic and reflective language designed to support modularity and security. It was built to some extent on his earlier work with mix-ins, which is a theme that I've been very interested in his work all through. And it supports both object-oriented and functional programming. And my connection with Gilad goes back a long, long way to his thesis on the programming language Jigsaw, mix-ins, modularity, and multiple inheritance, in which he introduced a lot of interesting operations for putting classes together. Instead of having a class hierarchy, you would have combination operations. And when Bill Harrison and I were working on combination of inheritance hierarchies and looking at operators for combining hierarchies, which sort of boiled down to operators for combining classes, I looked at Gilad's work and found it really compelling, and thought that if object-oriented programs were made up and composed in his way, rather than being the somewhat more rigid hierarchies, then everything would be a lot more elegant and our work would have been a lot easier. So clearly Gilad has done a lot of fascinating work in areas that are very interesting to this community. So I'm really pleased to welcome him to talk on modules, dreams, and reality.
Thank you, Harold, for that introduction that, you know, I'll put it on my tombstone since it's so much nicer than the reality. In any case, thank you for inviting me, and thank you all for coming early in the morning, though I know you expected a different talk, so I can sort of turn my back and you can all politely kind of leave if you want to. I'll be the substitute teacher for this morning. So, modules, dreams, and reality. So, of course, this is my take on things, and someone once told me that I had a gift for insulting my audience and making them like it. So hopefully this won't be too controversial, but there certainly will be points here that may not go over too well with the aspect-oriented community. In any case, my view of reality and modules, we have to define what we're talking about modules, right? And this is an interesting point, because if you were a mechanical engineer or something, you wouldn't be agonizing, you know, wringing your hands over what a module is. They kind of know what a module is. That's because they have physics to keep them honest. We have software, it's malleable, we can do whatever, so we can create elaborate ropes to hang ourselves with. And I'm actually trying to derive a notion of modularity that is influenced by reality, by physical reality, at least my intuition of it. And so it really comes down a lot to looking at what hardware modules look like, because that's the kind of modularity that makes sense to me. So those of you who have been at eCoop will find some of these slides painfully familiar, but you know, too bad. You should have known that when they invited me. So we have here two hardware modules. We've got radio alarm clock, and we've got an iPod. And this particular alarm clock lets you plug in your iPod, right? So it's plug and play. Pretty simple notion. You stick in your iPod, and then when the alarm goes off, it plays music from your iPod. So plug and play is an easy concept, but in software we can't really have easy concepts, because otherwise we wouldn't be, you know, able to show how smart and important we are. So we have to give things fancy names. So this is dynamic module configuration, right? It's happening at runtime. These things aren't hardwired in advance. We have a fondness in computer science for trying to solve everything in advance. We like to know stuff ahead of time. We like to statically figure it all out so we can optimize it and write complicated papers about it. But in fact, most module systems, software module systems, have a real hard time with this sort of thing. The other interesting thing is they plug into each other, right? They're connected. This is the nature of physical connections, is they go both ways. And of course, we have to have a fancy name for that. So of course, generally you can't do that in most module systems, right? We like to define these things so they're acyclic, and sort of mutually referential things like that are often problematic. And my goal here is to make the point that in my view that's absurd. It's just completely unacceptable to not support mutual recursion among module definitions. Another interesting thing about hardware modules, if you look at hopefully you can see there are 3 buttons on this clock. And they're all kind of the same. They have different labels, and of course they do different things. They're connected to different functionality in the clock, but otherwise these buttons, they're very simple. They're very similar to each other. They all come from the same button factory, as it were. And so we have multiple instances of the same design. And this is also something that we find often difficult with a lot of traditional modularity approaches. So typical, what passes for modularity in programming languages most of the time are things like packages and modules and all their cousins, and they can't do squat. So there's no mutual recursion. You're basically stuck with a single instance of a design per run, because the module and its definition are the same thing. There's no distinction between instance and declaration, which makes it really hard to do interesting things and define varying configurations and so forth. And it all boils down to the fact that modules are second-class citizens. They're not first-class values. They can't be manipulated, reflected, passed around, etc. That's sort of at the heart of this. So what are we going to do about it? Well, look again at this idea of multiple instances. So designs can be instantiated multiple times. Okay. Does the word instance ring a bell for anyone? Guess what? We have these things called classes which we instantiate. We also know that designs are hierarchical and they nest. They can be parts of bigger designs, and classes can sometimes nest. Now, depending where you look, you can find very elegant ways of nesting classes, or you can look in the mainstream and find things that don't work. So do not think of, this is not Java's nested classes. Then, of course, there's this issue that designs themselves are artifacts in physical space, right? Before everything got virtualized and became bits and so forth, right? There were things like blueprints, things that you could hold in your hand. You could store them somewhere. You could send them by mail, snail mail. You can manipulate them. And again, in a lot of systems, you can do that with classes. They're artifacts in sort of artificial space, and sometimes they can be manipulated. All of which brings you to what is actually a very obvious idea, which is to use classes as a unit of modular design. Now, if you've actually ever tried to find a system that does this, or thought about how you would do it, it turns out that it's a little trickier than it might seem, which is why it really hasn't been done, until fairly recently. But it's a very intuitive idea, right? Just why do I need all these extra mechanisms? Classes and objects should be enough, and they are enough. They just have to be handled in the right way. Which brings us to Newspeak, as you knew and feared. So Newspeak is a nice transition from the reality part to the dream part. It's a dream come true. So what is Newspeak? Newspeak is a dynamically typed class-based programming language. And it has 2 properties that are a little unusual. Each one is fairly unusual, and putting them together is more unusual still. One is this idea that all names are late bound, right? And when we say all names, we mean all names. And the other is that there's no global namespace. So how does this work? And what does this have to do with modularity? So as you might expect from what I've been leading up to, Newspeak modularity is completely based on classes. There are no packages, templates, features, bundles, you know, whatever, mechanisms, no aspects either. And it's just classes and objects. So classes nest, outer classes constitute modules that contain inner classes. So let's look in a little more detail about, at this idea that all names are late bound and what implications that might have. So one implication it has is that you can't refer to variables, at least not directly, right? All you can do is use accessor methods, right? Now this doesn't have to be awkward. It doesn't require you to say get blah 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 and set blah. You know, it doesn't have to be heavyweight, right? If you think about it in advance, it's actually more lightweight than traditional usage. And it gives you, obviously, representation independence, right? It's a very basic thing about module systems is we try to avoid having the module advertise what storage scheme it's using, right? So you get that pretty much for free, and you get it not only in other objects, your clients, but also in your subclasses, and you even get it in the class itself, right? There is no code that is using no code anywhere, actually, that depends on the representation. The only thing that changes is the declaration that says that this is my representation, as long as you preserve the interface, right? If you get rid of a field, you might have to introduce a method that, with the same name that produces the suitable result. But no usage anywhere ever changes, even within the class itself. So that's kind of handy, and that's not new. Self sort of had this sorted out 20-odd years ago. In fact, a lot of the ideas here do come from Self. Another thing you can't do is refer to classes, which might seem a little odd given the emphasis on how classes are the sole construct for modularity. But again, of course, you refer to them, but you don't refer to them directly. What you're doing is getting at them via accessors. So essentially, you can think of as a first approximation, every usage of a name, you can think of it as a virtual method call. So this implies that classes are first-class objects, right? They have to be returned by these accessors. In fact, this whole idea of going through late binding on everything pretty much implies that everything is an object, because the notion here is of an interface that is a traditional object-oriented interface. It's a set of methods, a procedural interface. And if everything goes through that, essentially everything has to be an object. And this fits well with the idea that designs are first-class objects. If we're going to represent designs by classes, classes are our first class, helps us. We can manipulate them, store them, do all those nice things. But we get a lot of other things. The nice thing from sort of a language design viewpoint is you get all these things for free. Once you commit to this idea that you're absolutely going to make everything go through late binding, everything is going to go through an interface, a lot of properties just fall out very nicely. So you get virtual classes, not because you had to decide to make classes virtual, but because there's no other way. All references to them are going through late binding, and therefore you can override them. You can override a class with a method, you can override a class with a plot, and vice versa. So virtual classes are there automatically. You get mix-ins automatically for much the same reason, because your superclass is just a name that's late bound as well. So you cannot hardwire your class declaration to a superclass. Effectively, every class declaration is introducing a mix-in. Now, you can make this syntactically easier to use in some cases, but basically you have mix-ins. Again, you have to have mix-ins. You can't do it another way. And which means that you get to class hierarchy inheritance, which Harold mentioned, so it's been an embarrassingly long time for both of us since that paper, probably 92, something like that. But yeah, we get class hierarchy inheritance for free as well. Because what you do is you nest entire hierarchies in outer classes, and then if you choose to override any particular class, the whole hierarchy, gets configured much through the mutual recursion between all the calls. So that's kind of nice. I mean, there's a lot of economy of mechanism. And we're going to see how this actually plays out, but first we should talk a little bit about this idea of no global namespace. So this is where we start talking about modularity more directly. So classical mechanisms like imports are are tied to this notion of a global namespace. If we have a module, this module lets us explore brave new worlds, as is appropriate for Newspeak programs. And it turns out that it needs a list implementation. So you'd import it. In this case, we're implementing a standard ordered list, mutable array list, and we'd import it from some collections module. The problem is that collections is a global name. Right? All these systems, even if imports are done the quote proper way, like in Modula, as opposed to the Java way, where they're just aliases, at least the import mechanism is hitting on a global namespace. In Java, everything is, because you can stick fully qualified names willy-nilly anywhere. It's bad style, but there's nothing to stop you from doing that. But even if you do it, this way, then the import itself is going to refer to some implicitly defined global namespace where all the modules live. And there's only one instance of a module in a running program. So this ties us, this hardwires collection to our program collections. Whatever the collections module is, there's going to be this specific one. And if hardware worked this way, then when I left Brazil, I'd take this cable with me, and I'd pull, and eventually there's a power station somewhere at the other end, and I have to take it on the plane with me, because that's how software is. It's infinitely malleable. We can create all these wonderful things that make a lot of sense. So I'm not fond of imports, if I wasn't being clear. But the related problem is, of course, this import declaration, it's nested inside the module, or the thing that pretends to be a module. Right? And this is confusing two things. It's confusing module definition, which is what this declaration of Brave New World Explorer is, with module configuration. So those things should be separate, and modules should be configured from the outside so we can actually have multiple independent configurations of them. But once you stick these imports inside them, and then they're coupled. So that's a huge problem. And we want to get away from that, and we're going to get away from that using the mechanisms of using classes exclusively as module definitions in Newspeak. So here's a module definition, Brave New World Explorer, but a module definition is simply a top-level class. Now there's no global scope, so a top-level class basically has to have every name that it's going to refer to available as a member of the class. It has to come from somewhere, either be defined by the class itself, or sometimes there's a few things like basic types like string and stuff that you can get by assuming that the language defines them effectively by defining members of object that you can inherit. There's nothing that can come from the outside world except in some explicit manner, which I'll detail in a moment. So where are we going to get mutable array list for this implementation? Well, we have to define a member. We'll define a slot called mutable array list. This is a field or slot definition, and it's private, so no one has to care about it outside the class. And this will, of course, induce automatically an accessor. So everywhere else in the body of the class, we'll have this accessor, and we'll be able to call mutable array list. But of course, I'm sort of begging the question, which I will continue to do several times throughout this talk till we finally get to the answer. Because the question is, okay, so now I have this field, but where did I really get the mutable array list? So I'm assigning this field based on this expression, and if you can't read sort of small talky syntax, imagine lots of dots and parentheses in between here in the spaces, and all will be well. So apparently what I'm doing is there's some object called platform, and the idea here is that platform represents the underlying platform, just as .NET or JVM or whatever. We always have a platform somewhere, except here it's reified into an object. And I'm going to call it, I'm going to invoke a method on it. It's called collections, and this is supposed to get me a collections library. Again, libraries are objects. They're instances of classes which possibly nest. In fact, let me show you what collections looks like. Oops. It's probably a little small, but this might be better. So collections is a top-level class, and in it there's various things, but does this still scroll? Yeah. So there's a list of nested classes here. bags, collections, what have you, right? So if we click on collection, oops, hello, right? So this is a class, actually the root of the collection hierarchy in the collections class that represents the entire module, right? So this is actually a very simple use of this mechanism where the whole library of collections is simply packed into a single top-level class, and you can get at it. Oops. So back to our regular scheduled program. So that's collections. And then I'm going to invoke mutable array list on it. Basically, that's an accessor method that's going to get me the mutable array list class. And so now, I had an instance of this library, I got a class out of it, I assigned it into a slot, and it's available. But I'm still begging the question, because there's this little question, where did platform come from? So platform came from over here, of course. And you probably can't read this, so I'll explain what this means. The only purpose of classes at the base level in a Newspeak program is to be a factory for instances. Most introductions to OO will tell you this, but you'll then find that it's not really true, and classes do 20 other things. But anything else they do is at the meta level, and in Newspeak is accessed via mirrors. What you want to do with them at the base level is to make instances. So they're factories. Essentially, the factory pattern is baked in. And when you declare a class, you give a method signature. Whoops. That's not what we wanted to do. You give a method signature. And in this case, it's a method called usingLib. And it takes a platform as an argument. And that implicitly defines a factory method, which you can invoke on the class object. It's a class method, not an instance method, but class methods are instance methods on class objects, of course. They're not static, they're not Fortran subroutines. And so that will create a new instance and initialize it, and the initializer is right here, and the formal parameter to the factory is in scope. So that's where platform comes from. And we're still begging the question, because so now that's the definition, and it's independent and parameterized, and that's very nice, but we still have to configure the damn thing. So, module configuration. Everybody's used to main methods. Have main functions, Java has main methods. Basically, most systems have an agreed entry point, a standard protocol for starting up an application. And what we're trying to do is to configure an application out of a bunch of modules. So we're going to actually make this happen. We don't have to do it this way, but this is sort of the standard idiom for doing it. We're going to make it happen in the main method. Now, this is the main method. It has two arguments. This argument is the usual stuff, the command line arguments, whatever. We don't really particularly care about it in this case. What's different is that there's a platform argument. So the idea is going to be that we will configure a module somehow, and then when we actually need to run it, the system will, by convention, call its main method and pass it the current platform object or reification of whatever it considers to be the valid platform that this thing is allowed to run. And then it can use that to help configure all the modules in it and start running. In particular, what's of interest to us here is Brave New World Explorer, which we are configuring simply by calling its using platform factory, passing it the same platform argument that we got from here. And we're doing a bunch of other stuff with it, all of which will eventually result in an open window that will run the application, and I'll show that in a moment. But again, we're begging the question, because now that you're going to ask, where did Brave New World Explorer come from, right? There's no global namespace. Where did this name come from? So it came from a class that represents the application, as opposed to a class that represents the actual module that's the library code. Eventually, we're going to connect several such modules into a given application, and we're going to define a single top-level class as a module to run it, and that's Brave New World Explorer app. And what we're doing is the same old trick, right? We have a slot here called Brave New World Explorer, and we're going to initialize it somehow so that Brave New World Explorer has an accessor, and then it's available to the main method. And I'm still begging the question, and hopefully you fall asleep before either we get to the answer. So what am I doing here? The idea here is that this particular class is going to be is an artifact that I'm building in order to create a deployable object that I can deploy and run. And so at design time, I'm actually going to manufacture an instance of this, essentially using tooling. In our case, we like IDEs. We use it with an IDE, but there are other mechanisms. This is what you always do. You don't think about it, but effectively this is always what happens. Whenever you actually do something with make or build or project, right, there is some tool that is tying together things from a namespace you have available at design time, which is usually, in the case of something like make, it's just the file system. Right? There are directories, there are files, these things name things, and when I've gathered all the pieces I needed, and then I build the application, right? So we're just doing this uniformly inside the language. Now what happens here is we're going to, this class has a factory method called package using, and that's again a convention, and I'll show you how it works in just a second. But the idea is, well, we're going to pass it an object representing the namespace we have at design time, the IDE namespace, where I've gathered all the pieces that I need to build this application. And I can then send messages to that, including, in this case, it's very simple. There's only Brave New World Explorer, and essentially import them into this app object. The net result of that is going to be an object that points at exactly the pieces of code I need. It's going to point at the libraries that I need, because these are top-level classes. They don't point at anything else. There's no global scope. They don't drag in a whole lot of other objects. And the class itself, which has the main method, which is used for to actually start running it and configuring it and plugging them together. So we'll instantiate using the tools, and that instance can be deployed in various ways. The sort of conceptually cleanest way is to simply serialize the object. So let's have a look and see how that all works. So first I'm going to point you at Brave New World Explorer, because just so you believe that it exists. And in fact, it imports other things, but right here, let's see if we can make it bigger. This is the line that imports the list. And yeah, the actual slide is different because here I'm actually renaming this. So again, there's no special import construct. You don't need that. And because you're just assigning it to a slot, you can easily rename things if you want to and so forth. And the other thing to note here is all the external dependencies of this thing are listed up here because of this idiom. Essentially, I know these are exactly the things that have come from outside that this code uses, because there's no way to get at anything else, right? There's no global namespace. So it forces me to actually enumerate very clearly what my external dependencies are. So let's look at Brave New World Explorer app and see how this actually works. Okay, wait a minute. I want it to be so I can make it bigger still. Well, this is as big as it'll go. Well, you can still see the whole thing. So this is exactly the code I showed you, ID namespace. Now the thing is, the ID recognizes that I have a class method called package using. And so it gives up these extra options that we didn't have in previous cases, right? These two little links, you probably can't read them in the back, but they say deploy and run. And they actually let me run the application or deploy it by essentially serializing it. So if I choose to deploy, I can deploy it as a Newspeak object. I can also produce a .exe. And if I deploy it as a Newspeak object, I get, you know, a 12 kilobyte file that has exactly the stuff I need, right? Because there's no more, no less. Even though it's object serialization, because these are self-contained, it isn't the typical case where object serialization brings, you know, the world accidentally with it. So we have a mechanism that lets us make modules parametric, it lets us connect them, and it lets us deploy them efficiently. And if we run it, we'll get this little thing that lets me browse files and stuff. Doesn't really matter what it does. It looks at directories and so forth, right? But it does run. Where did my slides go? Right, so when we actually want to run this, what does run do? It can take a serialized instance like this deserialize it. Now I have an object with a main method. I call the main method with a platform object, and it starts running, and that's how I run things. So this actually works in a very practical sense, but there's lots of things I want that are very nice about this. Obviously, since the module declarations are classes, I can have multiple instances. Another thing, the modules actually act as sandboxes. Because there's no global scope, the only way to hook this up to the rest of the world is from the outside by passing in things to the factory method. And so I can control, because it's externally configured, right? Unlike an import, which demands things and says, I want this from the outside world, this can only sort of request them. It can only work on the parameters it's given. So you have complete control of what you're giving it. It's reified via parameters, either the platform object itself. You can give it a platform object that is more restrictive. You can check what this thing, you look at the top of the definition and you can actually see what it's using, and you can give it a platform object that doesn't give it access to other things. If I want something that can't write to files, well, I give it a platform object that doesn't allow you access to a file library. So it's very much in tune with the object capability approach that Mark Miller has pushed in E and is trying to get into JavaScript in some form. And that's sort of a very nice fit with security and object orientation, a very natural fit. We can, as I said, create multiple instances. This slide shows you a parsing library, actually a parser, Newspeak parser, being instantiated with two different parser combinator libraries, because it's based on parser combinators. It subclasses from the parser combinator library, but you can give it different implementations. So you can have concurrently two different configurations of the module, and there's nothing special about that. It's just instantiating classes. This also shows that you can have two different libraries, two different library implementations, which implement the same interface, right? Again, just as we typically do this with objects, right? We can have a different class with the same interface. Now we've raised this to the level of whole libraries, frameworks, modules, whatever. By this, and we haven't really introduced new mechanism. I don't like a lot of mechanism. I'm not smart enough to cope with all these complicated things, so I like things to be very, very simple. Right, we've said all that. And so overall, we find this connects this idea of I'm calling it message-based programming, right? This late binding thing in the small messages in the small talk sense, potentially synchronous. But it also works for asynchronous, right? Again, it's a very natural fit with actors, in certain styles of actors at least, where the actor is actually an object that gets messages directly. It's basically an instance of a regular object with a thread of control. And that's a very natural fit. Works well with the object capability model, as I said. Works great with mirror-based reflection because, again, if I don't want my code to do reflection, or I don't trust this code to do reflection, I don't have to go start checking the stack and seeing who's permitted or doing any of those things. I just make sure I don't give it a platform object that will allow it to reflect. And I can control how much it reflects. I can give it a platform object that will give it a mirror library that will only reflect on its classes but not on others. You can do this in various ways. You get all these nice features, virtual classes, et cetera, all for free. And they behave very uniformly because the classes and the fields and the methods, they all follow the same classical rules that you're used to from straight method override and so forth. So it gives you it's very much a component style approach, and it does a lot of stuff that otherwise, in other parts of the world are done by very, very heavyweight mechanisms. A friend of mine was at EclipseCon last year, and there was a talk about OSGI, and someone explained with a straight face that OSGI was very simple. There were only 28 kinds of API. Okay? So what lightweight means to different people, I guess, is open to interpretation, but I'm sort of on the conservative side. Okay, since this is part of an advertisement, what can you do with Newspeak? Well, you can download it here. At some point, we'll put out a new release. That release is over a year old. A bunch of issues. The newest stuff, we have to get permission from SAP for some of the latest things we've done. We've done a lot of stuff before that, which still hasn't gotten out. One of the things that I hope we can release is we can actually now compile Newspeak to JavaScript and run it in a web browser. Again, we can basically, that same deploy option that I showed you will let you figure out exactly which classes you need to have, and if you can translate them to JavaScript, you can create a web page with exactly the stuff you need and spit that out. So modularity actually pays. It doesn't pay you guys, but it pays the world. That's why you're here. Of course, this is, an ongoing thing, and funding for this ran out a long time ago, so it's a volunteer effort and not moving nearly as fast as I'd like. But I think the ideas are worthwhile in my humble and totally objective opinion. So now we can move on to dreams. What does this have to do with dreams? Well, as far as I'm concerned, I'm the realist and you're the dreamers. So cross-cutting concerns and such, they don't really map neatly to individual physical components. So a notion like this of physical reality is very nice if you're trying to do that sort of thing, but a lot of people in this room wanted more. Whether it's possible to do more is debatable. The beauty of software is, yeah, we can hang ourselves, right? You can try and do virtual things that can't happen in physical reality. And the downside, there's nothing to keep you honest. You can shoot yourself in the foot and all the way up to here repeatedly. And, you have to be very careful to be consistent, to be simple, because there's nothing to stop you. So, again, Harold mentioned mix-ins. I've mentioned mix-ins. Many of the examples that I've seen in this line can be done with mix-ins. Not all of them, but many can. Those that can, we can do with the approach I've outlined, and it just falls out. But of course, you're going to ask me, what about the cases that don't? And I'll say that, modularity in the sort of sense, that's a book by Baldwin and Clark. They have a very nice definition of modularity that basically means, as long as there's an interface, whatever the interface is, there's an interface. The user can use anything that complies with the interface. The implementer can do anything they want as long as they comply with the interface. But they don't really necessarily tie you to any notion of interface. The notion of interface I'm using is a classical object-oriented one. But if you try to map that into something else, well, what's the interface for join, whatever, join points, cuts, all that stuff? It gets very, very complicated and intrusive. The interface is, yeah, my code is doing this at this point. It's kind of advertising a lot of stuff that, yeah, you can call it an interface, but it's really internals. And so is there any hope for what you're doing? And this is where I turn uncharacteristically positive and say, yeah, you can repent. There is hope. But I don't think that what's being done and has been done for a long time is the right approach, right? What I think that people are trying to do here is capture rules that govern the structure of a system. And those rules cut across. But if you're trying to do that while still kind of manipulating a classical imperative language, then your interfaces are going to advertise a lot of detail that you don't really want to advertise. And so I'd argue that the way to move this forward is to go to a higher level. I think rule-based stuff is going to come back in a big way. It sort of went out of fashion because in the 80s it sort of didn't scale well. But we can scale a lot more. Nothing scales forever, but practically speaking, the range of stuff that can scale today is much, much larger. And I think that looking into rule-based systems, logic-based systems is where you might actually be able to achieve these dreams without getting tied into these nasty mechanical problems that I see today. So a few words about related work. There's far too much, and no doubt I will insult someone by not mentioning something, but obviously self and small talk are very closely related to the structure of the language. Many of the ideas come from self, but they're applied here in a class-based language. Class nesting done properly comes from beta. In fact, it was the inspiration for the Java class nesting, how something happened to it along the way. There's a whole lots of work on virtual classes. my ECU paper sort of discussed a lot of that related work, and the thing is, most of that work won't let you do the sort of thing that I'm doing here because of an unfortunate obsession with types. There is, of course, work on class hierarchy inheritance, which goes back to Harold and Bill, and there's probably a few other people who have done work in that. Mark Miller's E, I've mentioned. You can't not mention Racket. So units in particular were an effort that's kind of in this spirit. There are ML modules. Another thing you have to mention, even though ML modules violate some of the key ideas like first-classness, mutual recursion, etc. And there's 25 years of research on ML modules trying to make them do part of that. So, you know, it's impressive, but it doesn't really do what I want. Of course, critics of AOP have to be mentioned, and I'm very fond of their work. And yeah, there's a lot more to say, but I'm not going to say it. These are some of the people who worked on the original Newspeak system. These are some of the people who have volunteered and done work since we went open source. And this is what you need to remember. And thank you very much for enduring this politely.
Thank you. The session is a bit truncated because of the various changes in schedule, but we have time for a couple of questions.
Make sure you don't give Mira the microphone. She's next. That's
Hello.
okay. Oh yeah, that's okay. I'm just practicing defensive. Yeah. Mario, yeah.
Okay. I have one question concerning the language. So when you say there is good synergy between, for instance, object capabilities and and security within Newspeak, then I subscribe to that point of view in the sense that Newspeak can be seen as some kind of, okay, to make the point, let's say, assembly language which allows you to relatively easily provide different models of security. Because when you say, okay, I use some object which provides capabilities, and then, okay, I only use that specific part of that object, or I create a new one which extends it a little bit and so on, don't you, in fact, create new models of security? And that, for instance, for security, is a rather very difficult issue. So the other security model, for instance, is probably much more hardwired. But on the other hand, everybody knows it. Its properties are known. You know how to use it. And yeah, okay, Newspeak provides much more flexibility. So do you think it's really useful when you go much more to the end user?
So I guess I'll agree and disagree, which is always a nice wishy-washy way to approach these questions. So if you relate this to, there are basically two schools of thought, right? There's access control lists and there's capabilities. And yes, the properties of the other model are well known. It doesn't work. That's its key property. We have the whole world in a colossal mess because 30 or odd years ago, 40 years almost, the world went with that approach. And so we have, you know, tons of problems, and they're only beginning. You know, cyber warfare is in its infancy because of that. Now, I don't regard this as an assembly language, right? There's an issue with having an actual security architecture, right? Our current implementation runs on Squeak. It has no security properties whatsoever, okay? Because you can always get at the underlying Squeak system, right? If it was a pure Newspeak system, we could seal things off, and we'll get there. The actual artifact that we've built, you know, is based on a system which had the complete opposite approach. It's all about openness and letting people experiment and whatever, and it's totally naive with respect to how the actual world works. So there are lots of proofs to be pointed in terms of actual architecture, of figuring out what the APIs, what the pieces are. But this is not for the end user to experiment. This is for the platform to define. And you can rightfully say that until you show this to be a secure system with all that entails, which who knows if I'll ever have the resources to do that, I haven't really proven that. What I'm saying is that the structure of the language makes this a natural fit. It's relatively easy to do that. You don't have to worry about the language undermining that model. Mira.
Okay. Let me first start by saying that I have always admired your work and admired today too, and it has been the mixins were the starting point for my work. So there are 2 people in this room at least in this community that started their career on
every soul you
advanced.
Corrupt is a win.
Well, yeah, I started with mixins and tried to do them more dynamic, which I think is also in you like it, and ended up in this community. But now back to the talk. I like virtual classes. But in your system, you get this late binding of classes, or classes that can be bound late along one dimension, right? Because they are nested. Is that true?
They are
nested into each other. So nesting is the way by which you achieve late binding of class names.
Uh-huh.
Doesn't this restrict you to one dimension of variability?
Well, because you can mix, well, actually there's more than just the nesting, actually, when you think of it, right? Because you can late bind to things that are slots that are coming in from the outside. Basically, they don't have to be nested in the same definition, right?
Okay.
There's lots of ways you can configure them together. So I guess that, hopefully that also answers the question.
Yeah.
And we're not, particularly restricted by that. And we have the GUI, the IDE, all the system that I actually showed briefly, right, actually works this way. We can compose real systems very nicely from this.
So the scenario I have in mind is like a graphical object being displayed in an editor, in a graphical editor, and the graphical object may show different things. So it can be the graphical representative of A, B, C, D. And you want the definition of the graphical object to vary with the editor itself might vary. So you want the graphical object to be late bound based on what editor it is being shown and based on what it is showing.
Okay, so the tricky part here is whether you want two things to factor in. I mean, it's easy enough to make it vary on either one of these, and you can make them mutually parametric or something. But if you actually want to make them vary on itself, you're going to have to do some mechanism, right? You're going to have to set up a table or something that looks at both of these, right? It's late bound. You can always do it, right? But you will have to do some of that dispatch yourself.
It's like
probably.
multi-dispatch on classes.
In this case, it sounds like that. I haven't really thought a lot about that, but you'd probably have to do some of the mechanics yourself.
I'm going to end the questions now to keep the session on track and encourage anybody to come up to Gilad during the break and talk to him some more. So thank you very much, Gilad, for an interesting, thought-provoking talk.